Hello and welcome to SBC's Bonding and Grounding Training. The training you're about to receive is vital. Failure to follow proper bonding and grounding procedures could lead to unnecessary dispatches as well as interruptions to customer service. As we all know, both of those basically lead to dissatisfied customers. Even more importantly, failure to follow proper procedures could lead to personal injury or even death. Everything you will receive during this training has been checked against SBC's BSPs as well as the 2002 National Electrical Code. Whether you're in construction or engineering, special services, or even my department, installation and repair, it is your personal responsibility to make sure that you correct any and all bonding and grounding problems you find in the field. And even better yet, do it right the first time and eliminate the second dispatches as well as the potential customer complaint. Many of the service problems we face in the field today are due to improper bonding and grounding. It is your responsibility as an employee, as a technician, as a shareholder, to make sure that you do everything possible to drive costs out of our business as well as improve our customer service. Pay attention. I'm sure you'll be surprised at some of the things you'll learn during the training.
Mr. Anthony is right. Bonding and grounding is vital, especially in today's telecommunications arena of high-speed internet and data transfer. Our telephone system is constantly exposed to high voltage and currents from power contacts, induction, and lightning. As a result of exposure, we're always at risk of fire, cable damage, service interruptions, and personal injury. Bonding and grounding is the key to minimizing these risks. Hi, I'm Randall Sloan, an SBC INR technician. And throughout this training, I'll be taking you to various sites to discuss the different bonding and grounding applications technicians are responsible for. But first, let's touch on some of this training's basic terminology. Bonding is the electrical connection of two or more pieces of telephone hardware or connecting telephone hardware to hardware belonging to another utility to maintain a common electrical potential when our plant is hit by lightning or power surges. Grounding is electrically connecting telephone hardware to an effective electrical ground. An effective electrical ground can be a power system multi-grounded neutral, or MGN, a grounded neutral of a power system with at least 3 customer services connected, an extensive underground or buried cable system, or a specially constructed grounding network. All of our approved grounds fall into one of the following categories: metallic power service entrance conduit, power service ground wire, power service ground rod, which is provided by the electric company and to which the electric company is also attached, building steel, if the building steel itself is properly grounded, a specially constructed grounding network, or an extensive underground or buried cable system. All of these approved grounds must be bonded to the multi-grounded neutral. Before we go out into the field, let's discuss safety. One large safety factor is the difference of potential. A difference of potential occurs when there is a voltage difference between two sources, such as our plant and the power company's multi-grounded neutral. If the sources are bonded and grounded correctly, the voltage difference will be equalized with respect to ground. If there is a voltage difference, you may become the path of ground and receive an electrical shock. To prevent these dangerous situations from occurring, you must always check the bonding and grounding of your sources before touching anything. Your first course of action is to always properly test for electrical hazards using your 188A test set. You should always wear your safety glasses, and when required by safety practices, your hard hat and insulating gloves. As we become more comfortable working around power, we sometimes forget the importance of our insulating gloves, hard hat, and 188A. Don't let this happen to you. It only takes one mistake to cause serious injury or death. As you can see from this arc demonstration put on by the power company, it doesn't take much to create an arc. Once an arc is created, your clothes will begin to burn, as seen in this picture. So always wear your safety gear and use your 188A. If you ever suspect an electrical hazard, identify the hazard to protect the public and other employees. Never leave an unguarded hazard. Notify your supervisor and see that the responsible company or owner is notified of the hazard. All right, Marty, I'll meet you at the sack box. Well, Marty, what do we have here?
Here we have a rather large SAC box. It services an entire apartment complex on our college campus. Now, since our SAC is located within 6 feet of the power company's power source, our SAC box must be bonded to the power company's multi-grounded neutral. If you'll take a look at the power company's ground rod there, you can see that we've already bonded to it.
Now, how did they bond to the ground rod?
Well, it looks like they took a locally approved ground rod connector, slid it down the ground rod, then took the number 6 ground wire, slid it up the back, and used a wrench to tighten it down with.
Now, don't we need to bond and ground the sack box itself?
Yes. Here at the sack box, we'll need to check for the number 6 ground wire. I just finished splicing and bonding this cable. First, I took the cable sheath bond clamp and attached it to the cable sheath. Then I took the other end of the bond strap and I bonded it to the frame itself. Then I checked all other bonds, and we're all done.
Well, thanks, Marty. Now let's take a look at a manhole. Earlier today, Marty came out and tested this hole for gases using his gas tester. After assessing that the hole was clear, he then pumped the hole using a submersible pump. After checking for gases again, he lowered a blower hose into the hole for a minimum of 5 minutes. Now this time will depend on the size of your manhole. You should refer to your purge chart for further instructions. And now that the hole is clear, we should retest for gas again.
Now, we need to retighten the case and bond the outside of the case to the bonding strap on the wall. To do this, we'll take this bullet bond here. We'll place our bond strap into the bullet bond, and using a socket wrench, we'll clamp it down. We'll then take the bonding strap from the case back to the bonding strap on the wall and attach them with a flat Fargo clamp. It must be a flat Fargo clamp to ensure good, safe bond. Now, these are the same grounding procedures that we'll use when working in a handle.
Now note that this demonstrates a preformed closure application. If using a different type of closure, be sure to follow the recommended bonding and grounding procedures for that closure. This is the same procedure as used in a handhole. Let's go take a look. Marty will meet us there.
If you take a look here, you'll see that we have the same type of splice case that we had in the manhole. And here's a bond strap on the wall, just like the one in the manhole. Now, I've inspected all the bonding and grounding here, and everything seems to be in good shape. Again, the bonding and grounding procedures that we used here are the same as the ones that we used in the manhole we just worked in.
Well, it looks like our next job is a pedestal with a multi-grounded neutral vertical, or MGNV. Now, to the common person, this just looks like a wire going up the pole.
As with the sack box, Randall, if we're located within 6 feet of the power company's power ground source, our pedestal must be bonded and grounded. First, I'll use my 216 to open the pedestal with. Then it's my responsibility to check for an uninsulated number 6 ground wire, leaving the pedestal, going to the power company's power ground source. And here it is. In this case, it's an MGNV.
Now, what if the ground wire were insulated or somehow improperly bonded and grounded?
Well, then it would be my responsibility to notify my supervisor of the situation. Engineering may have to get involved, but whatever the case, SBC is going to have to quickly and properly bond and ground this pedestal to avoid possible dangers to people using our phone system and our plant itself. To not report or correct the problem is only going to endanger lives and material.
Oh, we definitely wouldn't want to take that risk or liability. Now, normally you would bond all the cables to the pedestal housing, but I can see you've already done that. I guess we'll see that example at the next pedestal. The next pedestal we're checking is grounded to a power transformer. Marty, tell us about the bonding and grounding at this pedestal.
Well, Randall, I just finished splicing this cable here, as you can see. And of course, I made sure that each cable was individually bonded to the pedestal. Then, I bonded both ends of the number 6 ground wire here at the pedestal and at the transformer case as well. Now, the contractor actually places the original number 6 ground wire. If you take a look at the transformer case, you can see that I bonded the number 6 ground wire to the attachment provided by the power company to create my bond.
Marty's about to head up to the aerial cable in his bucket truck. He'll be taking all of his safety precautions first.
First, I've attached my lanyard to my bucket truck and then to my body belt before leaving the ground.
There are a few more safety precautions he'll need to take.
Next, I'm going to perform a self-test on my 188A. Then, I'll test the strand and the vertical to make sure nothing up here is energized or hot. Then I'll place my B temporary bond from my ground source to my strand to ensure my safety. Everything else looks good.
Before Marty goes any further, let me tell you all of the instances in which you might need to bond and ground on aerial cable. Grounding of the cable is achieved by attaching to the MGN. Bond and ground at the beginning, at the end of the cable run, at power crossing or at power transformers, risers, and at least every quarter mile. Bond at each crossover of cable when separate hardware exists. Bond at each branch of cable when separate hardware exists. Any break in the strand should be bridged with a permanent bond. Bond all down guys. Bond to down guys directly and not to the bail of the strand vise. Bond across all cable openings, such as splices and terminals, to keep sheath continuity. Now, let's get back to Marty.
In this application, I'm going to discuss the proper procedures for bonding and grounding self-supported cable to the vertical ground and bond across the sheath opening. Now, while Randall was discussing aerial bonding and grounding procedures, I've already bonded to the vertical ground. Now, since this second cable is attached to the same through bolt as the down guy wire, I've bonded the strand to the vertical. This bonds the down guy wire as well, as you can see there. Now I need to attach the strand to the wire. This is very important because with the older clamps, it's often done wrong. The teeth of the strand clamp need to go into the strand itself. Many people do this backwards, unless they're using the newer clamps that are easier to work with. Make sure you do it right. Now that I have the teeth of the clamp going into the strand, I've effectively grounded my strand to the vertical, and I'll demonstrate bonding across the sheath opening. This is important to preserve shield and sheath continuity.
Marty is right, because in today's high-speed communications environment, an open sheath or missing bond has the potential to allow unacceptable induced power influence on our telephone cable. It is essential to ensure that the proper bonds are installed at all cable openings to maintain sheath continuity. Failure to follow proper bonding and grounding procedures on the cable sheath can result in the loss of revenue, unnecessary man-hours, and dissatisfied customers.
Exactly.
Our next application of the day is a building terminal with a bus bar. This particular type of grounding arrangement is becoming more and more common. Let's take a look.
Here we have a customer-provided ground run, straight to a small bus bar. Now we meet this bus bar, carry our number 6 ground wire to our building terminal. Now this bus bar is brand new and it's been done correctly, so our day is done.
Well, we've seen several good examples of bonding and grounding. Most were construction related. However, construction, special services, and I&R all are impacted when it comes to bonding and grounding. We're a team here at SBC, and our main concern should be service, customer safety, and protecting our plant. With that in mind, we must all do our part and take responsibility for proper bonding and grounding. Poor bonding and grounding impacts all of us because it impacts our customers' service and safety. Poor service means more business for our competitors and lower stock prices for us. Protect your future by protecting our plant with proper bonding and grounding.
Thank you, Mr. Williams. On that note, we'll join Tony Lopez, our I&R technician, to see what bonding and grounding applications he can show us. Hey, Tony.
Hey, Randall. It's good to see you. As you can see, I've been over here at the side of this customer's house working on their phone lines.
Now, do you have any bonding and grounding responsibilities here?
Of course. I have to ensure that the network interface, or ONI, or SNI, or NID, is properly bonded and grounded. For example, in this case, the existing ONI is served by buried drop. If you take a look here, you can see that the ONI was installed properly because it's less than 20 feet from the power entrance. Ideally, We try to get these as close to the power entrance as possible.
So, Tony, can we take a look inside?
Sure. Now this buried drop has a metallic shield, and all metallic shielded drops should be bonded to the grounding bar, the O&I. This drop wire is connected to these gas protector units. These units help protect our customers against power surges. Now note that this O&I is served by a number 10 ground wire. We can use this ground wire if this O&I serves anywhere from 1 to 6 lines. You can use a number 12 ground wire, but only if you have 1 or 2 lines.
So what's the purpose of the ground wire at the O&I?
This ground wire serves as a ground path from these protector units to our multi-grounded neutral. This system is designed to divert power surges away from our customer's telephone equipment to the MGN.
Now I see that the buried drop is connected to these grounding lugs. Why do we do that?
We bond the shielded buried drop to avoid the difference of potential you talked about earlier.
Exactly. Now I see that the ground wire is connected to the power company provided ground rod.
What we have here is the best ground source available. What we don't want to use is this power stack or power service entrance conduit, because in this case it's PVC.
Now what if it was metal? Would that be acceptable?
Yes, as long as you're on the power company's side of the meter. Now Randall, take a look over here at this other metal pipe. Although it may look like a good ground source, it's not an approved ground source because it's a branch circuit conduit.
Now what about this metal water pipe? Can we use it?
No, water pipes are no longer considered a good ground source due to the common use of plastic pipe. For all we know, there's a piece of plastic pipe buried under the ground here or on the other side of the wall. So you should never install a ground to a water pipe. Now, however, technicians who find an existing ground to a water pipe should test the ground with their own meter. If the test fails, then they should find another approved ground source.
So it's grandfathered, but we definitely don't want to install a new ground to a water pipe.
Right. We also don't want to use this pipe over here. This is a natural gas pipe. And for obvious safety reasons, you never want to bond to a natural gas pipe of any type.
Yeah, power surges and gas lines definitely don't mix. And safety is our greatest concern. Now what about driving a telephone ground rod? Can we use one of those?
The only time we drive a telephone ground rod is when a commercial power rod is not present. And the other approved ground sources we discussed earlier are also not present.
Now what if we have to drive a ground rod? What steps should we take?
Boy, you sure ask a lot of questions. Okay. First, you locate all your underground utilities and make sure you're wearing your insulated gloves when actually driving a ground rod. Using a hammer, drive the ground rod vertically into the ground. Once you've driven it to its proper depth, test it with your 188A. If a hazardous voltage is indicated, don't touch the ground rod and notify your supervisor. Now, Randall, when you use a telephone ground rod, it must be bonded to a cold water pipe or grounded building steel if one is present. The connection to the cold water pipe must be made within 5 feet of its point of entrance into the building. And this connection must be made using a number 6 conductor. So as you can see, the use of a telephone ground rod involves a great deal of time and material, and it drives up the cost of the installation. So ground your O&I to an approved ground source if one is available.
That's important, as are the gloves that you mentioned earlier that protect you from electric shock.
Another important point, Randall, is that when you drive a ground rod, it must be driven so that it's at least a foot under the ground, and that's per the BSP.
Okay, Tony. We've seen a lot here. Let's recap. Again, here are our approved grounding sources for this location. Metallic power service entrance conduit, power service ground wire, power service ground rod, which is provided by the electric company and to which the electric company is also attached, building steel, if the building steel itself is properly grounded, a specially constructed grounding network. All of these approved grounds must be bonded to the multi-grounded neutral. If you take a look at our buried service drop, you will see that we're using the most preferred grounding method, a power company ground rod. We've connected to the rod using a number 10 ground wire. Now let's take a look at how we bond the other end of this drop.
That would be our buried service pedestal. I'll see you there.
Hey, Tony.
Hello, Randall.
Well, what do we got here?
Well, now we're at the pedestal, looking at the other end of our buried drop. Now, there are several types of bonds available. Here, our drop is bonded using a C-clamp, also known as a butterfly clamp. Now, all our metallic buried drops should be bonded like this, with a few exceptions.
Well, like what?
Well, like a dairy farm, or if your local engineer instructs you not to bond in that area. Or if the buried drop is served by an aerial cable and is less than 700 feet from here to the house, then you should not bond this end. Now, in instances where we don't bond, we should identify the drop with a tag that states, "Do not bond BSW drop." to let others know why we left it unbonded. Now, these drops should also be wrapped with 3 layers of vinyl tape.
Well, now does this mean that we don't have to bond at the outside network interface?
No, we always bond at the network interface. Now, if you find other drops in the pedestal you're working on that are not bonded, it's your responsibility to bond them immediately.
You should also check to make sure all the cables are properly bonded, like Marty showed us earlier.
Right. Now, there are several reasons why these bonds may be left loose, such as cable or fault locating. That's why it's very important to check to make sure we have a good tight bond in our cable. I've already checked the bonds in this cable and everything looks good.
Well, thanks, Tony. Next, we're headed to a job with aerial cable. Tony is up in his bucket truck working on our aerial cable. Let's go to him for our first step.
My first step before I ascended was to put on my hard hat, safety glasses, and lanyard. Then I tested with my 188A. And had this been an opening where the bond had been temporarily removed, I would have attached my temporary B-bond across the opening to maintain sheath continuity. Now, this section of aerial cable has a splice, and any time a technician opens an aerial splice, it's very important to check to make sure the cables are properly bonded. For example, here we have double sheath cable. With double sheath cable, it's critical that both inner and outer sheath continuity be maintained. This is done by first placing a bond on the inner sheath, then placing a bond on the outer sheath at a different clock angle. The bonds are then strapped together. Continuity is maintained across the sheath opening by connecting the cable ends to the closure bond bar or using a bonding strap. So we want to do this right the first time. Now I want to check this aerial terminal over here. This is what I suspected. There's a loose bond in here. I'll correct this problem, and before I descend, I'll make a visual check of all my cables to make sure they're bonded to the vertical, as Marty outlined earlier. Once I descend, I'll check my vertical to make sure it's intact. If there's a problem there, I'll fix it. I'll wrap this up and head to the sack box.
All right, Tony, what bonding and grounding responsibilities do you have here at the sack box?
Well, Randall, as an I&R tech, my main responsibility is to check to make sure my bond straps are securely attached in the box. If I have to get in the back of the box, I'll check for proper bonding and grounding. Remember, bonds may be left loose due to cable or fault locating. If that's the case here, I'll fix it.
Well, I think that wraps up the sack box. We've talked about bonding and grounding and how it relates to special services, construction engineering, and I&R. And we've said many times that bonding and grounding is critical to the safety of our employees, customers, and equipment. But now let's take a look at how bonding and grounding affects our equipment and services. For that, we go to Greg Olson, Senior Technical Manager.
With today's digital technology and DSL services, we're sending signals at higher frequencies and lower levels than we ever have before in our cables. Frequencies as high as radio signals. If bonds are missing from our cables, power influence in these radio signals are allowed into our cable to interfere with DSL services. Also, missing bonds allow working circuits on adjacent pairs to interfere with DSL signals. Here's a view of a spectrum analyzer. It shows the entire bandwidth that would support DSL service. Here's a good pair and a perfectly bonded cable. Notice that all of the interference is below the red line. This pair can support all of our DSL offerings. Now look what happens on an improperly bonded cable. See how these AM broadcast signals interfere with our DSL signal? This interference is sufficient to cause denial of DSL service. I see this often in the field. DSL is our future. We have to bond our cables to minimize this interference. We have to bond our cables to keep competing and meet our DSL service goals.
Thanks, Greg. We've seen a lot during the course of this production. I know I've learned a thing or two, and we hope you have too.